This is hybrid renewable energy system with variable DC loads allocated based on the fuzzy controller. Here the energy sources will be turned on and off with the help of the fuzzy controller. And if all the sources are not available, that is PV, fuel cell, and wind energy generation. These three are the hybrid energy generation systems. If these three is not available or providing less power, generating less power than that of demand, then the grid will be connected and provide the extra power. Here the fuzzy controller, it will generate 200 kilowatt. And PV, it generates 500 kilowatt. And wind power, it is generating 400 kilowatt. And there is three loads. One is fixed DC load. This is of nearly 250 or 300 kilowatt. After that, two battery energy storage systems are there. That is two electric vehicles. One is connected from starting, that is from t equal to 0. The next one, second electric vehicle, it is connected at the time interval of 0.4 second. From 0.4 second to 0.5 second, the second electrical vehicle load is connected. That is, second battery is connected. And the grid will be connected only if all the other sources generate less power than that of load demand. Here the fuzzy controller shows which one should be on, which one should be off. Here the fuel cell, it is of 400 volt, sorry, 360 volt, 400 amps, and it is given to boost converter. The boost converter output is around 1100 volt or 1000 volt, and the power is around 20 kilowatt. Sorry, 200 kilowatt. And this is PV. The PV is providing the power of 500 kilowatt. Is connected to boost converter. The boost converter will step up the voltage. The voltage is stepped up, and the power is around 500 kilowatt, 500 or 550 kilowatt. After 0.3 seconds, the power generation is reduced because the irradiation is reduced. This is wind energy power generation. Here the power generation is 400 kilowatt, base wind speed 12 meter per second. And from that wind turbine, torque is generated, and the torque is provided to the generator. And from that, we will get the energy. This is that is electric vehicle 1. Here the battery is charging from starting point. Here this is the battery. Yes, SOC of the battery. That is state of charge of the battery. Here the battery state of charge is increasing because battery is charging. And second battery, that is second electric vehicle, is connected at the time of 0.4 second. So until 0.4 second, SOC is constant. After 0.4 second, the SOC is increasing as the battery was starting to charge. And here this is the DC voltage. Here the power availability is changed. Initially wind and solar is available. After that solar power is reduced. So here voltage slightly reduced, and then when grid is connected, the voltage slightly again increased. Here this is the load power. First one is resistive load power. Okay, it is consuming nearly 300 kilowatt. After that, second graph is electric vehicle load. It is initially consuming 400 kilowatt. Then it reduced to 200 kilowatt. After 0.4 second, when second electric vehicle is connected, it is reaching nearly 600 kilowatt. Okay, these are the power generation. First one is PV power. It is nearly 500 kilowatt. After 0.3 seconds, due to the reduction in irradiation, the power generation is also reduced. Here, similarly, wind power generation, it is oscillating between 250 kilowatt. And fuel cell. Fuel cell, it is providing constant power. It is around 200 kilowatt. And fourth one is the grid power. Grid is initially 0 after 0.4 seconds when the second electric vehicle load is connected. The power generation is less than that of demand. That means demand is increased. So at the time the grid is providing the power. It is nearly providing 380 kilowatt. So these are the power generated and power provided by the grid to the electric vehicle loads and other DC loads. Here these are the availability of the power generations. Initially, the PV is available throughout the time period, and wind is available initially, and after 0.4 seconds, the wind is not available due to change in the wind speed. And third one is fuel cell availability. Initially, it was available. Then the demand is lesser than that of power generation. So the fuel cell is not generating any power. After 0.3 seconds, when the PV power is reduced, the fuel cell starts to provide the power. And fourth one is grid. Here the grid is not providing power until 0.4 second. After 0.4 second, when the load demand is higher, that is when second electric vehicle load is connected. At the time, the grid is providing the power. So these are the waveforms. We have to check it. DC voltage, then load powers, then source power, state of charge of the batteries, then that availability of the sources. Okay, these outputs we have to check it. Here, this is hybrid power generation, hybrid energy source are connected here. Fuel cell, PV, and wind power generation. And DC loads are connected. One is fixed DC load, then electric vehicle load. After that, after some time period, another load is connected. Yeah. Okay, due to the load demands, change in load demands, we can provide the energy, that is, we can allocate the energy to the loads sufficiently according to the load demand. Here, if the power generation is higher than the load demand, then appropriate sources will be providing the power. Initially, wind and PV is providing the power. After that, PV wind plus fuel cell is providing the power. And after 0.4 second, when wind energy is reduced and when the electric vehicle load is connected, extra load is connected, PV plus fuel cell plus grid is providing the supply to the load. So by the load demands and availability of the power, we can change the sources. What sources should be providing the power, what should be remain idle. Like that, we can choose it using the fuzzy logic controller.